Hello and namaskar. Hi, this is your educator Khushwant Fatnani welcoming you all to the session. Let's begin. जैसा हम हमेशा कहते हैं बैठे बैठे क्या करें करना है कुछ काम शुरू करते हैं आज की क्लास लेके प्रभु का नाम इन द डिवाइन नेम ऑफ गॉड लेट्स बिगिन विद दिस सेशन फॉर द डे वेलकमिंग ऑल माय लर्नर्स हियर हेलो आंचल गुड इवनिंग तनीषा हाय मकेश हेलो अलीजा हेलो आर्यन गुड इवनिंग जेसिका हाय प्रवीण हेलो स्वरदा गुड इवनिंग वासु तो आज की क्लास जैसा हम जानते हैं एज वी ऑल नो वी आर स्टार्टिंग विद अ न्यू चैप्टर नेम ऑफ द चैप्टर इज ऑसिलेशंस in many books it is also mentioned with the in the unit oscillations and wave you will also find this chapter as a part of the title SHM or simple harmonic motion. Before I talk about anything we are going to talk about certain applications. आप आसपास की दुनिया में इसे कहाँ देखते हो, where do you see it? Then we are going to see some questions which are or some basic formulas, some basic concepts, and then slowly we'll build our level step by step, one by one. One quick confirmation from everybody who is watching me right now, क्या आप लोगों को मेरी आवाज आ रही है? If yes, just raise your hand. We'll start with Aanchal and say a yes sir. We'll go for Aanchal. Yes Aanchal, you can put on your mic. Aanchal, ready?
Yes, sir, you're audible.
Okay.
Yes, sir.
Okay. Good evening Aryan. आवाज clear?
Yes, sir.
Okay. Aliza, good evening. Awaz clear at your end?
Yes, sir. Good evening.
Okay. All right. Good evening, Praveen. Awaz, the voice is clear at your end, Praveen?
Yes, sir.
Okay. Jessica, once again, a very good evening. My voice are you clearly? Can you hear me?
Yes, sir.
Okay. Makesh, one quick check of the voice. Can you hear me?
Yes, sir.
Swarada,
Yes, sir.
Tanisha,
Yes, sir.
Vasu.
Yes, sir. I can hear
Okay.
you.
Superb. So I'll share a screen here आप लोगों के साथ so that we can begin. And let me know when I share the screen if it's visible. Yeah. So Aanchal, screen दिख रही है क्या? Can you see the screen, Aanchal?
Yes, sir.
Okay. So we'll just share a new one. Okay. So this is the first class of oscillations. Also you will find this chapter in the name SHM, है ना? So let's start discussing. आप सभी लोग heading दे सकते हैं. You all can give the heading in your copies as oscillations. ठीक है? You can give the heading in your copy as oscillation. Or simply SHM, है ना? Any of the two headings you can write in your copy. 1 minute. My mic is, my mouse is processing something. What is it happening? 1 minute, huh? Just wait. क्या हो रहा है? Should I use the Zoom board today? It's not working right now. थोड़ी देर में use करते हैं if it works well. ठीक है. Okay, we'll work it on this one only. शुरू करते हैं. So give the heading everyone SHM है ना? Simple harmonic motion or simply oscillations. Oscillations. ठीक है, ध्यान से देखते हैं one by one. Let's have a quick look into every part of this. जैसा मैंने कहा, first we are going to talk about the basic applications of oscillations. So अभी suppose I ask you a question, Praveen. If I take a pendulum, have you seen a pendulum or a pendulum clock, Praveen? देखा है अपन ने? Have you seen it? Yes.
Yes, sir.
So suppose if this is a string of the pendulum, let me draw it here. Suppose this is the ceiling from which you have put the pendulum. Here is the string and now here is the pendulum का bob. ठीक है? This is called bob of the pendulum. Now you bring the string to certain height ऐसा. What do you think, Praveen, will happen to it? Will it stay here or something else will happen? Suppose you bring it till here and then you leave it. Over to you, Praveen. Yes.
Yes. The pendulum tends to move to the left side, sir.
It will start moving to the left side. Sure? Are you sure?
Yes, sir.
अच्छा, what about you, Tanisha? तुमको क्या लगता है? Will it start moving again downwards to it? Will it start moving left or will it start moving downwards left? Let's keep on
Downwards left.
downwards left. So anybody who thinks कि why this will happen? Aliza, ऐसा क्यों होगा? सोच के बताओ. Yes, Aliza. Over to you. हाँ, सोच के बताओ. Yes, Aliza.
Gravity.
Gravity. क्या gravity? अच्छे से explain करो. Yes, Aliza.
Sir, हमने उसको एक kind of like motion में छोड़ दिया है, so it will not stop until we interfere
Okay.
or until it loses its energy.
हाँ, सो नाउ अलीजा इज सेइंग कि सर आपने इस ब्लॉक को ऊपर की तरफ उठाया तो, बट एट दैट हाइट यू लीव इट, एट दैट हाइट यू लीव इट. तो इफ यू आर leaving a small bob at that height, there is some force. She is saying, sir, gravity is acting on it, and this gravity tries to bring this object back to its original position जहां से उसने चलना शुरू किया था. ठीक है, अभी सपोज आर्यन it comes back to this point. ठीक है, it comes back. Will it stop here? Aryan, will it stop here? What do you think? I raised it to a height. Suppose this height is h, Aryan. How much is it, Aryan? Suppose this height is h. So what will be the potential energy over here, Aryan, as it is at a height h from the ground? Huh? Loudly. Yes, Aryan.
mgh.
mgh. So Aryan, when it comes back to the same position, let's call this as position A and this is B. So when it is at B, what will be its level of, and what will be its value of energy? It will still be equal to mgh, or will it change?
Sir, at B or A.
At A, when it comes back to A, ऐसा. हाँ.
Potential energy will be 0.
Okay, potential energy will be 0. Then will its total energy be also 0, या total energy will be changed into some other form, Aryan?
Sir, it will be changed.
Which form? What is the another
Kinetic.
form? Kinetic. Suppose the velocity is v. तो बोलो what will be potential energy? Kinetic.
Half mv square.
This time kinetic energy will be half mv square. So if an object has half mv square, Vasu, do you think it will move ahead or it will still be there? If an object has an energy, kinetic energy, will it move ahead or will it stay there? Yes, Vasu.
Move ahead.
It will move ahead. Okay. So now when it moves ahead, let's take this with Tanisha. Tanisha, क्या ये फिर से ऊपर उठेगा because of this velocity या what do you think?
ऊपर उठेगा.
Okay. But then until what height will it rise, Tanisha? What do you think? H, sure?
Yes,
What
sir.
will be its new potential energy at this point, Tanisha?
mgh.
mgh. And at the highest height, again, what will be the kinetic energy?
0.
0. Similarly, here, if it starts from initial velocity 0, what is its original kinetic energy? Therefore,
0.
at 0. ठीक है. So what we understand is ये एक बहुत ही minimal example है. This is one of the most minimalistic example, one of the most simple example that I could give you. आप एक pendulum को उठाते हो, you take a pendulum, you raise it to a height h and then you leave it. It comes back to the central height and then यहाँ तक आते आते it has gained some velocity, again goes back to height and then again comes back. But Aliza, once again, what is the force that is acting on this object which is causing it to come back? कौन सा force है Aliza? Gravitation force. Now, suppose whenever this kind of motion happens, जरूर आपने देखा, you see there is some force. ये ऐसे नहीं होता, ये motion अपने आप से नहीं हो रहा. This motion is not happening by itself. There is some force which is making it happen. And Aliza says, sir, this force is called as gravity in this case. Now, suppose I consider this as the mean position of the object. Suppose थोड़ी देर के लिए, for some time we will call this as the mean position of the object. And now, suppose I talk about point A. Makesh, tell me at point A, is the gravitational force still acting or not acting on this object?
No, sir.
No, gravity is not acting when it comes at point A. Sure.
Yes, sir.
Come on. When you stand on ground,
No, sir. No, sir. Active.
gravity does not act on your what? Or it does? Tell me.
It acts, sir.
It acts. Okay. So now gravity is acting. But then again, please remember, we have talked about component of forces. हमने पढ़ा है एक फोर्स सिर्फ अपने आप में ना काम नहीं करता, एक फोर्स के अलग अलग components लिए जा सकते हैं. Suppose let's take this with Praveen. Praveen, suppose I have a force like this. Suppose this is F, okay? And now I want to resolve these forces. So what will be these two things called? Will they be called as components or something else, Praveen? Suppose components, okay. Praveen, so suppose one, I will try to draw it larger. Okay, suppose this is one F and then I'm trying to split it into two components which are perpendicular to each other. Okay, so Praveen, suppose this angle is theta. For some time, let us assume this angle that I draw here, this is force F, है ना? And this angle is theta. The angle between this line and this line is 90. So Praveen, tell me, what will this component be equal to, cos or sine? Over to you, Praveen.
Cos theta, sir.
Cos theta. And what about the component which is just perpendicular to cos theta, Praveen?
F sin theta, sir.
Very good. F sin theta. So we know how to split any force into components. Suppose here the pendulum is making an angle theta. Praveen, how much angle is it making with the vertical? Theta.
Theta.
है ना? Okay. Now gravity is acting vertically downwards. Am I correct, Praveen? Yes.
Yes, sir.
So let's try to analyze this. है ना? Let's try to analyze what is happening to this. Why is it coming down? Which component of force is bringing the pendulum down? ठीक है, कौन सा component है force का जो इसको वापस नीचे की ओर लाना चाहता है, which wants to bring it down, है ना? तो we'll take it here. अभी ऐसा, let's make this, and here this is theta. Suppose I will extend this bob का line, and this is also theta. So, okay, Praveen, do we see some similar kind of situation is being formed here also, Praveen? Yes.
sir.
Now this downward force is, instead of F, I'm writing mg, right? Abhi, we'll make one more component. Can we see that this, suppose I make a line which is perpendicular to the line of the string, suppose like this, है ना? So now this and this will be two perpendicular components of mg. Am I correct, Praveen? We can
Yes,
make two perpendicular components of mg. So now this one which I am drawing, what will its value be equal to, Praveen? Tell me.
mg sin theta.
Very good. So it will be equal to mg sin theta. And what about the component which is just perpendicular to it over here, Praveen?
mg
Yes.
cos theta.
mg cos theta. So can I say, Praveen, when this object is moving in this direction, it is actually mg sin theta which is allowing it to, or which is causing it to come along and travel along this line. Can we say that, Praveen?
Yes, sir.
I repeat, what did we just do? First thing, we analyze the motion of a simple pendulum ka bob. ठीक है? We are seeing that how if you lift it to a height, it will gain some potential energy, and now this energy will remain in it. Just that it will keep changing its position with kinetic. जब ये नीचे आया, potential turns to kinetic, and then it goes to the other side. वहाँ पे, यहाँ पे क्या होता है? Here all the kinetic energy again converts into potential, and ये cycle will keep on going. Ideally, if there is no loss of energy, this cycle will keep on going. After this happens, suppose we have talked about this. Now, we are trying to, second point, understand whatever we just talked about, ये क्यों हो रहा है? Why is it happening? We saw that there is some force which is responsible for doing it. और ये कोई ऐसा वैसा force नहीं है. This is not just era-gera force, right? No era-gera, no nattu-gera. This force has a specific logic and significance added to it. This force is called as restoring force. Aryan, what is this force called as? इस force को क्या बोलते हैं? Restoring force. Restoring word का क्या meaning होना चाहिए? What do you think, Aryan? हाँ, over to you.
It regains its position.
It is trying to bring the object back to its mean or original position. I repeat, what is restoring force? Jessica, ध्यान से सुनना. I will ask you to repeat. Restoring force is that force which is causing the object to come back to its original position or mean position. है ना? Suppose these are the two extremes of the pendulum. So Vasu, what can I call these positions as, extremes or means? The last two conditions or the last two positions, what can I call these as, Vasu? Extreme positions or mean positions if they are at the two extremes of the motion. Over to you, Vasu. Yes. Extreme positions. So here we are able to see that this pendulum is occupying three positions, two extremes and one mean. There is one force which is restoring force, which is trying to bring this pendulum back to its original position. And Praveen, how much do we think this restoring force is equal to in this case? How much do we think it is equal to? Once again, loudly. Praveen.
mg sin theta, sir.
Very good. This force is mg sin theta, which tries to bring this force back to its original position. Now, define restoring force, Jessica. क्या लगता है अपने शब्दों में बताना? अटकोगे, गलती होगी, कोई बात नहीं. It is always appreciated. It is good to forget. Yes, Jessica, over to you. ये restoring force क्या होता है, Jessica? What is restoring force in your own words? Yes, go for it.
Sir, the force that acts on a particle and brings it back to its mean position is called as restoring force.
Very good. वो force जो एक particle पर काम करके चाहता है कि वो वापस अपनी original position पे आ जाए is a restoring force. Now that you all get this, Aanchal, इस case में what is the value of restoring force, Aanchal? क्या है restoring
mg
force?
sin theta.
mg sin theta. Very good. Superb. Acha. Now this is one example which I wanted to give you all. Now, Aanchal, have we all read one very very important logic? And what is that logic? अगर theta बहुत small हो, if theta is very small or close to zero, तब हम क्या लिख सकते हैं? Sin theta is equal to theta. याद आ रहा है क्या? yes, ऐसा लिख सकते हैं
Yes,
आंचल?
sir.
तो साइन थीटा इज नियरली इक्वल टू थीटा ऐसे केस में अभी लिख लेते हैं. सपोज वील राइट एफ इज इक्वल टू mg sin theta, assuming that sin theta is equal to theta when theta is very small. Can we write like this? Yes. अच्छा, एक और चीज आंचल, अभी do we remember a formula from the chapter units and dimensions? S is equal to r theta. क्या होता है फॉर्मूला? रिपीट करोगे? Over to you आंचल. Yes, what's the formula? S is equal to
R theta.
वहां पे what is S, what is R and what is theta?
S is the length of the arc, R is the radius, theta is the angle formed.
हाँ, so we all have read when we were doing units and dimensions that S is equal to r theta is the relationship between length of the arc, radius, and the angle which is being subtended by this arc at the center. Suppose you have a circle, है ना? And from that circle you choose a small arc. This is a small arc that you're choosing. This arc has a length S and it is subtending an angle theta at the center of the circle, and R is the radius. We say that in this case S, R and theta have a relationship with each other. Suppose for some time let us call this distance as x. Instead of s, let us call this distance as x. So Makesh, tell me, what can we write theta equal to in terms of s and r? First tell me, what can we write theta? Make it the subject, then tell me. Yes, Makesh, theta is equal to, therefore theta is equal to, make it the subject, Makesh, s by
S by R, sir.
S by R. Okay. In this case, suppose I am taking S value as X. How much am I taking, Makesh? I'm taking X as S. Okay. Or S as X. Okay. So instead of here S by R, what can we write, Praveen? Makesh?
X by R.
X by R. And suppose in this case, this is the center and the radius is same as the length. Can we see that, Makesh? The radius is same as the length of the string. Yes. So instead of S by R, we'll write X by L. क्या ये clear हो रहा है? Are we clear on this, Makesh?
Sir.
Yes. What did I say? Repeat it for everybody. What did we do just now? Over to you, Makesh. Yes. Over to you.
Theta is so small, we take sin theta as theta, sir.
Okay. Then we have written that theta is equal to length of arc by radius. In this case, length of arc is nothing but equal to x, and the radius, that is the point which is connecting the suspension point to the bob, that radius is equal to length. Yes. Okay. So now, therefore, Aanchal, what's the value for force that we get? Therefore, F is equal to, bolo, mg
X by L.
Okay. Up there is one more correction that we'll introduce in this equation. Acha. Now, tell me one thing. I will ask this from Tanisha. Tanisha, as this block is moving towards the center, tell me theta is decreasing or increasing?
Decreasing.
Theta जैसे जैसे decrease होते जाएगा, as theta will start decreasing like this, है ना? Tell me one thing. अभी यहाँ पे theta will start decreasing. इसका meaning क्या हुआ? What does that mean? It means that if theta will decrease to some point, it is possible that its magnitude will become 0. Am I correct at the center?
Yes, sir.
Yes? Okay. But suppose in this direction, उल्टे direction में देखते हैं, in this direction, यहाँ पे theta will increase. Am I correct?
Increase, yes,
है ना?
sir.
Increase. तो we will see, हम लोग एक बात देखेंगे, as this object comes towards the center, theta is decreasing, away from the center, theta is increasing. अच्छा, force का direction क्या है? Is it in the increasing direction of theta या decreasing direction of theta, Tanisha?
Decreasing direction of theta.
I'll repeat it again, है ना? We have just seen कि इस direction में, in this direction, theta increases, इसके opposite direction में theta decreases. ठीक है? Very simple. अभी यहाँ पे object will come, suppose it is 60. If the bob is over here, it will become 60 से 30. And if the bob moves up, तब 60 से 90, etc. etc. So this is the direction of increase of theta. This is the direction of decrease of theta. So where is the force acting? Let us take this with Praveen. Praveen, where is the force acting? In the increasing direction of theta or decreasing direction of theta? Quickly.
Decreasing, sir.
Decreasing direction of theta. Now, Swarada, tell me one thing. If the force is acting in the decreasing direction of theta, can we choose to put a negative sign here? Can we choose to put a negative sign here? Why? Because in the direction in which theta decreases, force increases and vice versa. Or force का direction is the direction in which theta is decreasing. सही कह रहा हूँ, Swarada?
Yes.
Yes. है ना? चलो, everybody, let's have a quick revision of whatever we have seen until now. Let's have a look. First, we saw that there is a pendulum which can move between these two pointers. You took this pendulum to a height, certain height, some force acts on it, brings it back to its original position, and this vice versa thing can keep happening until time infinity. Then, along with Praveen, we derived that, sir, this force which brings back this object to its original position, that force is called restoring force. Jessica defined the restoring force for us. Then, along with Anshul, we understood that, sir, this sine theta can be written as theta because we have learned it in units and dimensions that for small values of theta, sine theta and theta have same values. After writing that, along with Mukesh, we also derived that theta can be written as S by R, and Vasu confirmed that yes sir, we are doing it correctly. Then we saw F is equal to minus mgx by L. Yahan pe, tell me Aanchal, is this L changing or this L is constant?
The L is constant.
What about mass and acceleration due to gravity? Are they changing or are they constant?
They are constant.
But as this object or bob is coming towards the center, is this x changing or is this x still the same?
It's changing.
So because this bob is moving towards the center, the arc length will keep becoming smaller and smaller. Arc is this length, hai na? This length is the x. As this bob keeps coming towards here, x is changing. So only x is variable in this entire equation. Rest all variables are, or rest all numbers or whatever figures that you have written are constant. So we all can write something from this, hai na? Have a look here. F is equal to minus mg by L into x. Remember here x is the only variable. सिर्फ x ही एक ऐसा number है या ऐसा figure है which is changing. This is variable. So can we say, Aanchal, that because of this change of x, this restoring force will also change? Can we say that? Yes. Can
Yes,
we
sir.
also assume that this is nothing but some constant k? Abhi we already most of the times take k as constant. So suppose, can we take that mg by L is a constant, right? Clear?
Yes, sir. So we'll get F is directly proportional to minus x.
So we get an equation F is equal to minus kx. ये equation is very known to you all. कैसे? We'll have a quick look a little later. पहले you all quickly put this down into your notes or just take a screenshot and then we'll discuss something else. Just take a screenshot. I'll give you time to write. ठीक है? So dear learners, kindly put it down into your notes. फिर थोड़ा सा और discussion pending है ना? Go for it. Yes. Or just take a screenshot. Anything. Once you all are done taking the screenshot, raise your hands. ठीक है? So Jessica, Aanchal, Aliza, Aryan, Vasu, Praveen, Mukesh, Swarada, everybody, please go ahead. Yes. Once you all are done with the screenshots, just raise your hands.
Excuse me, sir.
1 minute. We'll have doubt discussions. Just write it down for now. 1 minute. Huh? We'll have doubt discussions. थोड़ा रुक जाओ. Write down your query. जो भी है, we'll discuss. Even if there is a printing error, we'll discuss. Meanwhile, you all can write it. Five, 4, 3, 2, 1. ठीक है? Moving it to the next screen for all of you. Yes. So once again, if anybody wants to write or take a screenshot, 5, 4, 3, 2, 1. You can encircle this or put a square around it or rectangle around it, whatever you want. Okay? This is the restoring force. Okay, please remember in this equation two important parts. This F is the restoring force, है ना? This F is the restoring force, and this X is the displacement from the mean position. This X is the displacement from the mean position. We will also take one more example. ठीक है? क्यों हो रहा है, क्या हो रहा है, etc. We'll talk about it later. ठीक है? Mean position. So Aryan, ऐसा एक force और याद आ रहा है क्या? Have we read this kind of force somewhere? Do you recall, Aryan, in the chapter Work, Energy and Power, while talking about springs? Do you remember now, Aryan? हाँ. याद आ रहा है क्या? While talking about
Yes, sir.
springs, we have read about this force. क्या याद आ रहा है? Tell everybody. Yes, over to you, Aryan. हाँ.
Elastic energy.
Okay. और suppose I
constant.
have a spring. हाँ हाँ, you were saying something. बोलो बोलो. Yes.
Spring constant.
हाँ, so elastic energy, spring constant कुछ याद आ रहा है. Suppose I have a spring. ठीक है, it is connected to a wall. यहाँ से I start stretching this string. मैं string को stretch करना शुरू करता हूँ, ठीक है, and we have some extension in the string. Say this extension is in right direction and we make this as x. ठीक है, what will you observe? Let's take this with Makesh up, or let's take this with Swarada. Swarada, what will you observe? Will this spring, suppose you are standing here and you're trying to pull this towards you. So Swarada, what will you observe? Will this spring try to stretch you towards it, or will try to push you away from it? Over to you, Swarada. Yes.
Try to pull me towards it.
So the spring, as you are applying a force on the spring, suppose the force that you are applying is denoted by this green color arrow. So this spring will try to apply a force in the opposite direction. Let us make it with red in color, है ना? तो जब आप स्प्रिंग को राइट में खींचते हो, स्प्रिंग आपको लेफ्ट में खींचती है. आई रिपीट, व्हेन यू आर ट्राइंग टू पुल द स्प्रिंग इन द राइट, स्प्रिंग इज ट्राइंग टू डू द ऑपोजिट. इट विल ट्राई टू पुल यू इन द लेफ्ट. And therefore, Aryan, अब याद कराओ, therefore, there we had talked about spring force. किसकी बात की थी Aryan हमने? We had talked about spring force, and the spring force is given by, suppose,
F equal to minus kx.
we had also read this equation there, F is equal to minus kx, which was given as F is equal to minus kx. Again, what kind of motion is this, Aryan? What kind of motion is this here? The spring here, the spring, 1 minute, just 1 minute. ओके, या सो लेट्स रिज्यूम. हम क्या बात कर रहे थे? सो आर्यन सेड कि सर यहाँ पे वी कैन वेरी क्लियरली सी कि हियर ऑल्सो देर इज अ फोर्स एक्टिंग, एंड दिस फोर्स इज ट्राइंग टू ब्रिंग दिस spring back to its original position. So Swarada, can we also say that here this F is also restoring force? Swarada, can we say this?
Yes.
Yes. And यहाँ पे what was X? X was the extension of the spring.
Extension.
है ना?
Yeah.
Extension. और we can also say that extension क्या होता है कि तुमने spring को अपनी original position से कितना खींचा. Am I correct, Swarada?
Yes.
Yes. That how much did you pull the spring from its unstretched position? So here spring was unstretched. Spring was unstretched, whereas in this case you have stretched it. तो छोटी छोटी बातें, these are simple pointers, key pointers that we wanted to connect and understand कि कैसे कोई एक ऑब्जेक्ट अलग अलग तरह से ये वाला फोर्स एक्सपीरियंस करता है. हाउ डज एन ऑब्जेक्ट एक्सपीरियंस दिस फोर्स? फर्स्ट वी आर अंडरस्टूड द सेम हैपन्स फॉर अ सिंपल पेंडुलम. देन वी टुक द एग्जाम्पल ऑफ अ स्प्रिंग. यहाँ भी वही होता है. इफ यू ऑल वांट यू कैन राइट दिस, दैट दिस construct or the main diagram that we have drawn is for a simple pendulum. हमने पहले इस चीज को पाया कि एक simple pendulum के लिए phenomena था, ठीक है. It was some phenomena for a simple pendulum. Same equations, same kind of equations we saw comes in case of a spring. अच्छा, I'll tell you one more simple logic where you can again recall we have also encountered upon this before also. तो दिस इज स्प्रिंग फोर्स एंड देयरफॉर लेट्स राइट हियर स्प्रिंग. ठीक है, ओके. अच्छा, रिवर्स इज ऑल्सो ट्रू. ठीक है, इफ यू विल टेक द स्प्रिंग ऑन द अदर साइड, इफ यू विल ट्राई टू कंप्रेस द स्प्रिंग, लेट्स टेक दिस विथ मकेश. मकेश, सपोज यू डू द रिवर्स. ठीक है, सपोज यू कंप्रेस द स्प्रिंग लाइक दिस, है ना. यू कंप्रेस इट एंड दैट कंप्रेशन इज ऑल्सो suppose in this direction x. Where do you think the spring will apply the force? Towards right or left? Over to you.
Right, sir.
In this case, the spring will try to apply the force in the right direction. ऐसा. Again, what should this f value be equal to? It should again be equal to f is equal to
Minus
kx, opposite direction of x. Here the spring is compressed. So here it is. Let's write compressed. No? Compressed. If you all want, you can draw it along with me, or later you can write it from your notes, whatever you want. I'll send the Sunday notes and today's notes together. Okay? Write it down. Okay, I hope you all have written it down. Now, let's proceed. Okay, one more time, let's try to understand. Aryan, do we remember what is the formula for Young's modulus? Over to you, Aryan. Yes.
Yes, sir.
Tell us क्या होता है. Suppose I have a spray or a simple elastic band. ठीक है? I start stretching it and it comes to a new length. Suppose the original length is L and the final length is capital L. Suppose this extension is delta L. So that we can write that the new length is equal to original length plus delta L. ठीक है? Now this could happen because we are applying a force F. This could happen because we are applying a force F from both sides. So suppose same force this elastic band is also applying in this opposite direction, which we call as the restoring force. याद आ रहा है? Yes, restoring force. अब because of this force, suppose and also इसका cross section area, suppose the cross section area for this band like this area is A. ठीक है? हाँ. What is the formula for Young's modulus? Strain by stress or stress by strain? Over to you, Aryan.
Stress by strain.
So we know stress per unit strain is given as value for Young's modulus. Swarada, do we remember what is stress, what is strain? Over to you, Swarada. याद है क्या?
Yes, sir.
Stress is force per unit area. क्या होता है? बोलो loudly. Force
per unit area.
लेकिन कौन सा force? Restoring force per unit area. Which force? Swarada?
Restoring force per unit area.
Restoring force per unit area. Restoring force per unit area. And what is strain? Tanisha, do we know strain क्या होता है? What is strain, Tanisha?
Yes, so it's del L by L.
So del L by L. Achha, does it have a unit by any chance or no unit?
No unit.
No unit. So please remember it does not have a unit. Achha, what is the unit for force per unit area? Achal, याद है क्या? Do we remember? Force per unit area का unit is?
Newton per meter square, Pascal.
And this one has no unit, sure. Achal, what do you think?
Yes, sir, it doesn't have any unit.
Why?
Because it's a ratio between L and L, so the meter and meter get cancelled.
Okay. Achha, here, suppose I call this as X. Suppose उसको थोड़ी देर के लिए we call X. कह सकते हैं? Yes. Achha, can we say that in this case, stretching has happened, so X is in this direction? है ना? Yes. Can we see, Aanchal, that the restoring force and X are acting in the opposite direction? देख पा रहे हैं क्या? Can we see that?
Yes, sir.
Yes. Achha, with that logic, suppose I want to make F as the subject. Suppose मैं F को subject बनाना चाहता हूँ. What will we write? Let's just write it easily. F by A is equal to X by L, and here we have, this is original length L. ठीक है? हाँ. And here we have Young's modulus Y. हाँ. क्या लिख सकते हैं? Let us make F as the
So we
subject.
get
हाँ.
Y into X by A into L.
हाँ. So Praveen, can you extend it further? What is Aanchal saying? Y into X by L into A. Correct? Praveen, have a look. Just check if this is correct. Yes, Praveen. Over to you. Have a look. Yes, Praveen.
Yes, sir.
Right? Okay. Can we see one more thing, Praveen, over here, that F and X are in opposite direction? Once again, can we see that F and X are in the opposite direction?
Yes, sir.
So if I want to write it with sign, will we put a plus sign here or minus sign? Yes, Praveen. Here, force and displacement are in the opposite direction. You are trying to pull this elastic band towards right, है ना? Whereas the restoring force inside that elastic band is acting towards left. So tell me their directions are same or opposite?
Opposite, sir.
So should I put a minus sign here or plus sign?
Minus, sir.
Very good. Superb. So since x is positive, force will be negative. If x is negative, force is positive. So tell me, Aryan, one more thing. Do we know that here we take area and Young's modulus and original length as constant? All of these are constant. Am I correct, Aryan?
Yes, sir.
Yes. So from that logic, can I write here k is equal to ya by L? Aryan? Yes, Aryan. Over to you.
Yes, sir.
Okay. So from this, can we write f is equal to minus kx?
Yes.
Same equation once again, है ना? Correct? Same equation once again. तो what are we trying to prove? हम इतनी देर से क्या कर रहे हैं? What are we doing? Why are we doing it? क्या लगता है आर्यन? Oh, your inference. We'll take one line inference of 3 examples I've given you, है ना? हमने 3 examples दिए, nothing else. Just quickly one by one जो हमने पढ़ा है, whatever we have read until now, we are trying to relate that with what we all are going to learn today. जो हम पढ़ने वाले हैं उससे हम कनेक्ट करना चाहते हैं उससे जो हम पढ़ चुके हैं, है ना? we are trying to connect the dots. So we'll take one line inference from everybody of you. आपने क्या क्या सीखा? What have you learned until all of these cases? But before that, let us take and Vasu, do you remember what is the potential energy of the spring? Vasu, do you remember what is the potential energy of the spring?
Yes, sir. Minus K.
No. Once again. Any try? Okay. No worries. So, let's take this with Aryan. Aryan, याद है क्या? Do you remember what is the potential energy of the spring? यहाँ पे not string, spring. हाँ. Over to you, Aryan.
Sir, 1/2.
1/2. 1/2 loudly. Kx square, है ना? Vasu, read it out loud. Potential energy of the spring is given as
1/2 kx square.
once again full statement. Potential energy of the spring is given.
Potential energy of a spring is 1/2 kx square.
Okay. Now one by one, from one in one line, all of you have to give your inference. आपने क्या समझा? What is your understanding right now? हम क्या कर रहे हैं? You can either give a summary, right? One line summary, or you can tell your inference. आपको क्या समझ में आया? Like in English we have passage, unseen passage. You are taught something and then you are asked your reference. We'll start with Vasu. Yes, Vasu. Over to you. What is the inference that you could get from three examples that we saw? That of a simple pendulum, that of a spring, and that of an elastic band. Over to you, Vasu. Yes. What is the inference that in anything that you could learn? It can be something that is written, it is something that is there in your mind, any conclusion, anything would do. Even one line would do, just one line. Over to you, Vasu. Yes. Hello, Vasu, are you there?
Yes, sir.
Your one line inference, what are you trying to understand from the 3 examples that we have seen? Any idea? Yes, Vasu. Any thoughts?
Sir, there are a few things in common.
Loudly. Something is there in common. Loudly. Once again. Over to you, Vasu. Hello, Vasu.
Yes.
Loudly. Any one statement, it's okay. Don't think that anybody is judging you. No one is judging you. Yes, go ahead. Quickly. Loudly. That?
So that f is equal to like minus kx.
This f is equal to
common.
Good. So f is equal to minus kx statement is there in everybody, and just keep raising your hands once you are done. Okay. So now Vasu, you can raise your hands, right? So now Swarada, your one line inference about what could you learn from suppose the first one, this one, simple pendulum. What could you understand from whatever we saw in simple pendulum? Over to you, Swarada. Yes. Hello. Yes. Hello, are you there, Swarada? Okay, seems to be a network issue. No worries. Over to you, Achal. क्या सीखा अपन ने Achal from the simple pendulum experiment? Yes.
Oh, that a restoring force is required, multiplied by a constant is required in every case for the oscillation of the pendulum.
For some kind of oscillation of the pendulum. Now Achal is introducing a term to us. She's saying, sir, in this case pendulum will oscillate, है ना? And pendulum will try to bring this object downwards, and some kind of force will act which is somewhere proportional to the displacement. So Achal, tell me one thing. If I increase this force, if I increase this x value, should force increase or decrease in terms of magnitude? Don't consider minus sign. Over to you, Achal.
It will increase.
Increase. So Praveen, my next question to you, can you also say that if you decrease this force, if you decrease this x value, force will decrease?
Yes, sir.
Right? Okay. Now, Jessica, tell me one thing. If you will try to increase this force, will this will this x increase? Don't consider minus sign. Assume it's not there.
Yes, sir, it will increase.
It will increase. Will it increase? Now consider minus sign. Will it increase in opposite direction or same direction?
So the opposite direction.
Opposite direction. So, Jessica, you were saying that if I keep increasing x, f will keep increasing. Am I correct?
Yes, sir.
And if I keep decreasing x, f will keep decreasing.
Yes, sir.
If it means for less extension, less restoring force will act. And for more extension, more restoring force will act. Am I correct, Jessica? Yes?
Yes, sir. Yes, sir.
Okay, good. Now, all of these examples are telling us that something very unique is happening. In all of these cases, we talked about a very special thing which is f is equal to minus kx. ठीक है? We'll come back to it. इसके पास हम वापस आएंगे. We'll talk more about it. But for now, we are talking about a very, very simple thing which is called as a periodic motion. Let us understand ये periodic motion क्या होता है. So now, from the word periodic, we can see that something which is happening again and again, periodic. Abhi, for example, the planets ka motion, periodic motion. Let's take this with Praveen. Praveen, how much time does Earth take to encircle the sun or go around the sun? Yes, over to you, Praveen.
365 days, sir.
365 days or it...
Quarter.
Huh?
365 and a
Around-
quarter, sir.
And a quarter, and or around 365 days. Okay. So suppose here we have our blue planet, which is going around the sun, which is going around the sun. Let's make the sun here. Okay. Now, so does this happen every year in the same duration of time, or does this time keeps changing? Over to you, Praveen. Yes.
Same duration, sir.
Same duration. So in the same duration, this earth keeps going round and round and round and round. This is nothing but an example of a periodic motion. A motion that repeats itself in definite intervals of time. Write it down, everybody. Motion that repeats itself in fixed interval of time or definite interval of time is a periodic motion. Write it down, everyone. And now suppose you want to define this mathematically. So mathematically, we have certain examples of periodic functions. For example, I'll make you all read it right now so that it will become easy when we do the chapter. So first write, mathematically, suppose f of t is periodic. If f of t or a function of t is periodic, what is the meaning of it? Mathematically, इसका मतलब क्या है? Right? Is periodic. Then we can write f of t is equal to f of t plus capital T, which means that there is something which depends on time, and that something becomes same after every t time. I repeat, there is something which is depending upon time t, and after every time t it becomes again the same. मतलब function अपनी value को repeat करता है. The function repeats its value after t time interval, and here this t time interval is called period. मैं दोहराता हूँ, ध्यान से सुनना. The function reassumes its value. I repeat, function reassumes its value. Function अपनी value को बार बार प्राप्त कर लेता है. It again gains its value, है ना? Function reassumes its value, a same value after t time. हर टी टाइम के बाद अगर एक फंक्शन अपनी वैल्यू को वापस गेन कर ले, आफ्टर एवरी टी टाइम if the function gains its same value, then we will say that this function is periodic. This is in the language of mathematics, है ना. हमने mathematics की language में, in the language of mathematics and in general English, we have seen how periodic functions happen. Abhi let's take an example of a periodic function before we plunge into this chapter. ठीक है? Now we'll take an example. You all can take a screenshot if you all want, and I'll give you all the notes also if you haven't written. ठीक है? 5, 4, 3, 2, 1. Makesh, do you know an example for a periodic motion? Makesh, कोई example है क्या? Do we know about it? Yes, Makesh.
Simple pendulum, sir.
In maths, any function that you know?
Sir, sine, sir.
Sine and cos of x, some variable, are very excellent examples of periodic functions. When you will see the graph, you will understand that the graph is such that you will see the patterns repeating. ध्यान से देखना, ठीक है? अभी let's try to draw this. We all have done this. हमने पहले किया हुआ है when we were doing mathematical tools for physics. For those who had joined originally very in the initial stages will remember. Plus, since I had also asked you all to finish the syllabus from the beginning, many of you might have seen the videos, some of you couldn't have, but that's all right, no worries, do it whenever you all are free. Okay? So we have talked about sine and cos functions originally. Now sine of 0, let's quickly take this with Aryan. Sine of 0 is 0 or non-zero? 0? Yes, Aryan, are you there? Hello.
Yes, sir.
Sine of 0 is 0?
Yes.
Yes. Sine of 45 is
1 by root 2.
okay. Sine of 90 is
1.
1. Acha. What about sine of 120? Root 3 by 2?
Yes.
Okay. Okay. And then what about say sine of 180? 0 again?
Yes, sir.
And this thing keeps on happening until one complete round gets over. I repeat, यहाँ पर I asked Aryan some of the values of sine. मैंने उससे कुछ sine की values पूछी. And then I said that this will keep happening until a certain period of time. You will see that sine का graph कुछ ऐसा बन के आएगा. You will see the sine graph will come something in this pattern. ठीक है? Like this. I'll draw it again. And we'll try to connect these dots. To be very precise, I will draw these dots later, चाहो तो, or the best method is make the dots and then try to reconstruct the graph over it. ऐसा. You will see this is how sine function keeps repeating. इसी तरह से sine function अपने आप को repeat करता जाता है. If the graph is continuous, you will find this line ऐसा. 1 and then again and on and on. This will be called as one cycle. ये एक cycle है. This is called one cycle. One cycle. And when you will draw this graph repeatedly, you will see that ये वाला pattern keeps repeating. This is the second cycle and so on and so forth. Therefore, these are called as periodic functions. So if I will draw, like I'll name it, suppose, तो ये 0, this angle will be pi. Here x, remember, x is the angle in radians. ठीक है? Here x is the angle in radians. This is angle here that we are marking in radians. है ना? This is pi, ये 2 pi, ठीक है? And then again this will be more pi, which is 3 pi. This is again, so you might see that I have drawn it one, एक बड़ा हो गया, एक छोटा हो गया, but you will see that all of these are of the same length. This is just to adjust that I have drawn it this way. Otherwise, if I want to be very accurate or more accurate than this one, I could have drawn इस तरह का graphs. Have a look, ठीक है? Everybody, I'll draw it quickly for all of you. The graphs can look something like this. This is one line, y, and suppose here we have the x. It will keep on varying. ये one function, then again the same, and once again, and so on and so forth. ये पूरी कहानी चलती रहेगी. This will keep repeating, and here also it might not be very perfect, but I think you all get the essence of it. कि whenever we draw functions, whenever we draw periodic functions, so you will see that these keep repeating. Every cycle is exactly same to the previous cycle. Every cycle is same as the previous cycle. So we have cycle number 1, cycle number 2, cycle number 3, है ना? And the same function will keep on repeating. So not only sine but cos also follows a very similar kind of pattern, and remember its values are oscillating. Why do I say oscillating? Because it's 0, ठीक है, it reaches certain value, ठीक है, it reaches certain value, say 1, and then again comes back to 0, and then it again becomes, यहाँ पे it becomes -1. After that it certainly rises, comes back to 0, and then again becomes 1 over here, ठीक है, comes back to 0 here, and then again -1, फिर से it starts rising, है ना, and again becomes 0, and so on and so forth. तो ये cycle of going or dancing between 0, 1, -1, 0, 1, -1 will keep on going till x is equal to infinity. No limit to it. चलता ही जाएगा, चलता ही जाएगा, चलता ही जाएगा. These are also therefore periodic as well as oscillatory functions. इसीलिए these are also called oscillatory. Now what is oscillation we'll very shortly see, but for now you can just take a quick screenshot of this or write it into your copies if you all want. Yes, go for it. Take 1 minute and write it. Okay, I hope you all have written it down. Now let's continue. So we talked about periodic motion first, and then we took an example of sine function. ठीक है? A very similar graph can be drawn for cos also. So let's take this with Tanisha. Tanisha, where does cos ka graph start? Does it also start from 0 or starts from some other value? Yes, Tanisha.
Starts from 1.
Starts from 1. Okay. And will the curves be similar or they'll change? Will it be box format or similar the way we draw this? Similar. So abhi you will see cos ka graph starts from 0, starts from 1. So at this point x and y, we are supposed trying to plot a graph of y is equal to cos x. So it starts from x is equal to 1, ठीक है, goes down until this point which is x is equal to 90 or 90 degree or pi by 2, and then again rises to a height ऐसा this point, or ये phenomena will keep repeating itself. Again here also period is 2 pi, and then again this process repeats, goes down, comes back, comes back. So this is one cycle, ये वाला which I am drawing with red, this is one cycle, ये which I have drawn non-dotted part, ठीक है, this is one cycle of cos, and you will see that ये वाला thing will keep happening again and again. This pattern, if you see from this point, it will keep repeating, it will keep repeating. And यहाँ पे you can also do the other markings. This point is again, this point is pi, and ये वाला point is pi by 2, and this wala point is -1. Again between 1 and -1, again between 1 and -1, this entire graph keeps on going. Here also period is 2 pi, just like sine. Just like sine, here also period is 2 pi. In sine also similar thing happened. Usme just that graph started from over here. Graph started from here and then it kept on going. Isme graph will start from 1, isme graph will start from 0. This is the only difference. Rest things are same. ठीक है? Take a screenshot if anybody wants to, or write it in your notes. 5, 4, 3, 2, 1. ठीक है, I'll send the notes on the group, so please don't worry. अच्छा, अब you all have understood a lot about all of these things. अभी there is something called as oscillation. ठीक है, अभी we learnt about periodic. There is something called as oscillation. Oscillation in very basic or layman term is to and fro motion. To and fro motion. So if you have seen rides, है ना, if you have seen the rides in a fair, है ना, किसी मेले में अगर आपने झूले देखे हैं, right, or even a normal swing that you see, even a normal swing that you see. So this swing has the motion of kind which can be termed as to and fro. अगर हम आपने, if you all have seen how swings move. So the motion which swings take, जिस तरह से एक swing move करता है, suppose the way a swing moves, this can be called as a to and fro motion. जाना आना जाना, but एक ही part पे आना जाना. I repeat, going and coming back between fixed points and through same path. I repeat, कोई दो points के बीच में आना और जाना, but through the same path, right? Through the same path, through same path. When आना जाना keeps going, same path, ठीक है? When going and coming back is happening between fixed points, between fixed points. So suppose if the ये देखो, suppose these are the limits, ठीक है? Suppose between these limits ये swing is going and then coming back, going and then coming back, then I will say that this is oscillation. So oscillation is nothing but a to and fro motion where the particle is using the same path for to as well as fro, and this is happening between fixed limits. This is happening between fixed limits. So these are three certain pointers. How will you define oscillation? And between fixed points or fixed extremes. You can also call these points as extremes, the end points. So this is oscillation in very simple terms. Now let us talk about SHM. है ना? Now let us talk about SHM. ठीक है? What is an SHM? Let us understand. So oscillation, or in general terms also, SHM is only oscillation, but there is, why is this certain term defined? ठीक है? So SHM or simple harmonic motion, simple harmonic motion is a very very peculiar kind of motion. All of the motions that you saw here, ना, जितने भी motions आपने अभी तक यहाँ देखे, all of these the examples that we took, the example of that of ये spring को खींचना. You know what will happen if you will leave this यहाँ पे this force F, तो this elastic will not directly move to its original position. Rather आप देखोगे, even if the rubber band is there, you just pluck a rubber band. आप एक rubber band लो हाथ में और उसको pluck करो, you will see rubber band also, it oscillates at a very small amplitude. For a very small range it will also oscillate. So here also SHM goes on. Then in a spring, maybe if you press the spring and you leave it, so देखो it will start oscillating if it is fixed to a surface like this. Similarly, even if you take a pendulum and you leave it, it will also start doing a to and fro motion. So all of these motions that we have seen, spring, pendulum, it's difficult to, it might seem challenging to visualize it for an elastic band, but it might be easy to visualize it for a spring and pendulum. इन सभी में आपको एक समानता दिखेगी. You will see there is a certain kind of similarity in all of these kind of motions, and that similarity you all have already seen is that force is equal to minus kx. But this is not era force. This is restoring force. Jessica, can we repeat this statement? Which kind of force? What is F? What is X? And what is the statement? Over to you, Jessica. Yes.
So restoring force is that force that acts on a particle and brings it back to the mean position.
Okay, and then what is F here? What is X here? What is K here?
So F is restoring force, K is constant, and X is
displacement from the mean position. What is X? Once again, what is X? Displacement from
displacement from mean position.
Displacement from the central or mean position. From central or mean position. Good, very good, Jessica, superb. So everybody write it down into your notes. Displacement from mean or central position. ये simple harmonic क्यों बोलते हैं? Why do we call simple harmonic? We will shortly see. जल्द देखेंगे, ठीक है? Mean, displacement from mean position, ठीक है? Now, after you all have understood about F is equal to minus kx, ठीक है? Let's try to expand it further. थोड़ा सा इसको expand करते हैं, ठीक है? First write it down, take a quick note of this into your copies. Here we have three kinds of values. One is F, one is K, one is X. Here K is a constant we have already seen in each of the case. F is force, and it is not just force, it is restoring force, which is trying to bring the object back to its original position. And what is X? X is the displacement from the mean position, ठीक है? Now we'll move ahead and take this topic to a new level. Jaldi se. Once you all are done, let me know. Done, everybody. So 5, 4, 3, 2, 1. I hope everybody has written this. Bring a quick raise of hands अगर सभी ने लिख लिया तो. Everyone. Jessica, Aanchal, Aryan, Ridhima, Tanisha, Makesh, Swarada, Vasu, Aliza. Everybody done? Okay. So take a screenshot. If nahi liya to I'll go for a reverse counter before I finish. Take a screenshot. 5, 4, 3, 2, 1. Okay, I think Ridhima is watching us via YouTube. Harshit Singh is saying, sir, can anyone please let me know where can we take the admission for the class? Okay, so Harshit, you can contact me on my number at Harshit. Meanwhile, all of these are writing. Later, you can contact me on my phone number, which is 7974 355374. I repeat, 7974 355374. Right. Okay, good. I think Ridhima was also answering. Very good, Ridhima. Okay, superb. Everybody, I hope यहाँ तक हम समझ गए हैं ना? Everybody has understood this point of time कि what is simple harmonic motion? It is a motion which has this kind of restoring force acting on the object when its displacement from the mean position is x. Let us expand it further. ठीक है? And write down the heading. है ना? अभी heading बाद में लिखेंगे. First, let us see what we are doing. अच्छा, from आपका न्यूटन्स लॉज ऑफ मोशन. आर्यन, व्हाट इज एफ इक्वल टू मास इनटू acceleration. So if f is equal to minus kx, we can write ma is equal to minus kx, where a is acceleration and m is mass. Yes, Aryan, right?
Yes, sir.
Okay, Aryan, tell me one more thing. Can we write that a is equal to acceleration? Aryan, can we write a is equal to acceleration?
Yes,
And acceleration is what? Rate of change of displacement or rate of change of velocity, Aryan?
Velocity.
So dv by dt. Now, what is velocity, Aryan? It is rate of change of displacement. Very good. So we know that this is velocity, which is rate of change of displacement. Can we write a substitute velocity here, dx by dt? है ना? So what will it become? Single differentiation or double differentiation, Aryan?
Double.
So d2x by dt square. I repeat, how do you pronounce it? d2x by dt square is nothing but the value for acceleration जब आप उसको दो बार differentiate करते हो. So here also you can do the same. You can write this as dv by dt, है ना, into m is equal to minus kx, and therefore m times of d2x by dt square is equal to minus kx, and therefore इसीलिए can we take this m on the other side? आर्यन, ले जा सकते हैं? Yes.
Yes, sir.
है ना? क्या हो जाएगा बोलो? Expression will be, read it out loud. हाँ. I think your voice is a little unclear. एक बार loudly can you speak? Yes, over to you, Aryan.
d2x by
By
dt square is equal to minus kx by m.
Very good. Minus k by m x anything. अब do you know what do you do? हम ना यहाँ पर लिखते हैं, we just make a substitution. We take let. This sign is called omega. What is it called? Vasu, what is this sign called? Omega. Hello, Vasu, are you there? Loudly. Yes, Vasu. This sign is called as
omega.
Omega. So this omega square of omega is taken as k by m. Can you read it out loud, Vasu? What is square of omega taken as?
Omega square is equal to k by m.
So instead of this k by m, what can I write in the equation, Vasu?
Omega.
Omega square. What can we write, Vasu?
Yes, sir, omega square.
So d2x by dt square, we'll take it as minus omega square x. Suppose if I take it on the other side, Vasu, what will the equation become? Tell me, minus will become plus or minus will remain minus only? Yes, over to you, Vasu.
Sir, minus will become plus.
So what will the equation become? Read it out loud. d2x by dt square. Read it out loud, Vasu. Plus omega square into
is equal to x.
Into x. Omega
Into
square
x.
into x is equal to
0.
Once again, loudly. Over to you, Vasu.
dx square by dt square
d2x
plus
by dt square. Once again. d2x
d2x by
dt square is
omega square
omega square
into
x
is equal to
0.
0.
Okay. Now in mathematics, those who are math students, they will also read, plus sometimes this is asked in your school ka papers also. Now this is called as differential equation of SH. When This is asked in your JEE ka and NEET ka papers also sometimes ki identify which one of the following is the differential equation of the SHM. इसको हम कहते हैं, this is called differential equations of SHM. Differential equation of SHM. Please write it in your copies. Differential equation of SHM, है ना. इसको हम कहते हैं differential equation of SHM, है ना. We call it differential equation of SHM. अच्छा, next logic. Now, आंचल मुझे एक बात बताना, what is d2x by dt square? Is it velocity or acceleration? This one. Acceleration. तो हम क्या लिख सकते हैं? Therefore, for a simple harmonic motion, one conclusion we took is f is equal to minus kx. What is acceleration equal to? Minus omega square x. Can we write that from here? देखो आंचल.
Yes, sir.
From this statement, everybody have a look. From this statement, this d2x by dt square or double differentiation of displacement. See, simple logic. A or acceleration is single differentiation of velocity or double differentiation of displacement. पहले ही देख चुके हैं. I've seen it before, right? Now, we are writing that this acceleration can also be written as minus omega square into x from this expression. देखो, just that, take this on the other side and d2x by dt square की जगह you will write A. This is also another characteristic of an SHM. तो किसी भी SHM में the acceleration of the object which is oscillating or which is doing a simple harmonic motion, that acceleration should be equal to minus omega square x, where x is the displacement from the mean position. Displacement from the mean position. I'll write it loud. Displacement from the mean position. ठीक है. अच्छा, सेम थिंग. सपोज अभी वी ऑल हैव अंडरस्टूड वंस अगेन, एक बार दोबारा रिवाइज करते हैं. व्हाट डिड वी जस्ट सी? वी इंट्रोड्यूस्ड अ टॉपिक कॉल्ड एज SHM. हमने कहा ये SHM क्या होता है. अभी ना I told that SHM is something जिसमें f is equal to minus kx, first pointer. Then from that f is equal to minus kx we derived this equation and we called this as differential equation of the SHM. फिर we also wrote that we can also write now कि a is equal to minus omega square x. This is also a way of writing SHM. Sir, do we have a name for omega here? या omega के लिए कोई नाम है क्या? Yes, there is a name for omega. It's called angular frequency. क्यों बोलते हैं? You all will realize it soon. For now, write it angular frequency. Can you repeat this name, Vasu? What is this frequency called as? What kind of frequency? Angular frequency. Why is it called? That is a fact to be later discussed. For now, you all can write this is called angular frequency. Acha. Now there is one more characteristic of an SHM that you all need to go through, and that characteristic is SHM is a motion which is both periodic, that is it happens after a fixed interval of time, and it is to and fro, that is oscillatory. I repeat, SHM एक ऐसा motion है, right, which has both the characteristics. It is oscillatory in nature, and when I say oscillatory, it means it has a to and fro track. वो आगे जाता है, पीछे जाता है, आगे जाता है, पीछे जाता है. अगर ऊपर नीचे हो रहा है तो ऊपर जाता है, नीचे हो रहा है, ऊपर जाता है, नीचे होता है, बट अपने आप से नहीं होगा, राइट. सो इफ इट इज गोइंग फ्रंट एंड बैकवर्ड, इट वोंट हैपन बाय इटसेल्फ. फ्रंट बैकवर्ड, बट this entire phenomena will happen because of a force, and that force is called, Makesh, what is that force called? क्या बोलते हैं उस force को? What is that force called because of which this to and fro motion keeps happening? We gave a name to it.
Restoring force.
Restoring force. So restoring force makes sure that periodic motion and oscillatory motion are happening on and on लगातार, and we call this as SHM. अब ये SHM का क्या माजरा है सर? Why do we call SHM? ये क्वेश्चन आना चाहिए माइंड में. So now let us discuss that. ठीक है. Now let us have a quick, very short discussion on it. है ना? This is point number 4. Now suppose for now I take x is equal to sine of omega t. Please remember here omega is a constant. ठीक है? Omega is a constant. It is not a variable. Here x is displacement from the mean position. Displacement that we were talking about, but not just displacement. Displacement कहाँ से? From mean position. And t is time. ठीक है. अभी we are just assuming, suppose this is a statement. Before we assume this and take it ahead, आंचल हमको याद है क्या? Do we remember what is d by dx of sine of ax plus b equal to? सबको याद कराओ तो. Do you remember? We have done this. Thorough practice किया है इसका. Do we remember? बोलो. a times of cos ax plus b. याद आया? Yes, आंचल.
Yes, sir.
Tanisha, similarly, d by dx of cos ax plus b is, हाँ, over to you, Tanisha. Yes, बोलो. This is equal to minus a sin ax plus b. इसको loudly read करना है. Second one by Aanchal, first one by Tanisha. Yes, Aanchal, second वाला expression read करो loudly. Yes, over to you, Aanchal. हाँ.
D by dx of cos ax plus b equals minus a sin ax plus b.
Okay, how is it related to d by dx of sin x and cos x that we have seen? उससे क्या फर्क है? What is the similarity and difference? Yes, Tanisha, Aanchal.
We are using the chain rule in this one. First, we are differentiating the whole.
अच्छा, d by dx of cos x is
Minus sin x.
Tanisha, d by dx of sin x is
Cos x.
cos x. Easy, Tanisha. याद आ
Yes,
रहा है ना? Only difference that is there in all of these expressions is instead of x, when I have ax plus b, instead of x, if I have ax plus b, I will make sure that whatever is accompanying x, suppose a here, it comes outside the cos या sin का value. Rest everything remains the same. Differentiation of sin was cos, differentiation of cos was sin, minus sin. Only difference is I will put an a where a was the coefficient of x. A was the coefficient of x. So on the same rule, Praveen, on the same note, suppose I want to differentiate. Suppose I say this is displacement. First to tell me what should velocity be equal to. Praveen, over to you. What should velocity be equal to? Dx by dt or something else? Praveen. Huh. Hello? Okay, I think he logged out, right? Makesh, over to you. Yes, what should velocity be equal to, Makesh? Hello? Makesh, are you there?
Yes, sir.
Huh. What should velocity be equal to?
Sir, minus omega cos omega
No. That's later. First, tell me in terms of differential. V is equal
dx by dt sin omega t.
No. Simply dx by dt.
Yes, sir.
Once again, loudly. What is velocity equal to?
dx by dt, sir.
Once again, what is velocity equal to?
dx by dt.
Now, say it is rate of change of displacement. Loudly. Over to you. Yes, ma'am.
Rate of change of displacement.
Once again, not like this. Velocity.
Velocity equal to rate of change of displacement.
So now let us differentiate it. D by dt of. What will we write here? What is x? Makesh, what is x? Sine of
Sin omega t.
Okay. Now, do we know? Can we compare that instead of x we have t here, है ना? Instead of x we have t here, and instead of omega instead of a we have omega here. Can we see that, Makesh? Have a look.
Yes, sir.
Tell me again. What did I say? Yes, Makesh. Loudly. Huh.
Here instead of x we have t, sir, and instead of a we have omega, sir.
So instead of x we have t, and instead of a we have omega. So what should be the final answer therefore when you differentiate sign? What should come? Bolo, Makesh. Here we have a. So here we should have omega into cos
omega t, sir.
Why a? Only omega, right?
Yes, sir, yes.
Instead of, see, everybody get this a clear picture in your mind. We all have seen this. When we were doing mathematical basics, we all have seen that sine ka differentiation is cos. So sine of a plus ax plus b differentiation is a times of cos ax plus b. Only difference. In this case, instead of x we have t. Instead of a we have omega. And what is b here? Do we have a b here, Makesh? Do we have a b here? No. So here b is 0. Here b is 0. I repeat, हमने क्या किया? We have just taken a simple formula that we have already read. उसका application we have seen. We saw that when you differentiate x, suppose x is equal to sine omega t. You see on differentiating, this becomes omega cos omega t. Suppose Makesh, there was a here. अगर यहाँ पर एक a आ जाता, tell me, will the constant come outside differentiation or will it remain inside differentiation? Yes, Makesh.
Constant come outside, sir.
हाँ, suppose I have another constant which is placed in front of sign, तो we all are very well aware कि all the constants differentiation के बाहर आ जाते हैं ना, differentiation के बाहर आ जाते हैं, we get that. Now, therefore, this becomes a cos omega t. Suppose I will add a b here, जिसको हम b बोल रहे थे, suppose I will add a b here and I will call it phi. Suppose I will call, this symbol is called phi. What is this symbol called, Vasu? What is this symbol called? This is called phi. Loudly. Yes. Okay. Vasu, what is the symbol called?
Phi.
Phi. चलो. Let's continue from here in the next class, everyone. ठीक है, इसको थोड़ा सा देखेंगे. Right? We'll see it a little better in the coming class. For now, just write we calculated x is equal to a sin omega t. Later we'll replace it by phi in the next class. For now, you can write here it is 0. ठीक है. For now, you can write it is 0 for the sake of simplification. Rest explanation in the coming class. Take a screenshot. We'll meet at 9:15. ठीक है, we'll meet at 9:15. Take a screenshot, everyone. 5, 4, 3, 2 and 1. I hope सभी ने लिख लिया है. Thank you everybody. If there is any doubt, we'll discuss it in the coming session. आने वाले session में discuss करेंगे. 9:15 we all are catching up back again. Take care everybody. Goodbye. 9:15. Have your supper and we'll join back. Take care. Bye. Yes. Tanisha, कुछ कहना था? Makesh, do you want to say something? Okay. Alright. So for those of you who are watching us via YouTube, अगर आपके मन में किसी तरह का कोई सवाल या क्वेरी है, आप उसको नीचे कमेंट्स बॉक्स में लिख सकते हैं. आप इन्हीं बच्चों की तरह, like these learners over here, if you would like to come and be a part of this session. So I think Harshit Singh is saying, can anyone let me know from where can we take admission for the class? So Harshit Singh, you can reach me on my number, which is 7974 355 right? You can contact me on this number and be a part of these classes. And the fee for every month is rupees 3,000. And if you're joining for the year-long course, then for the year-long course it becomes 36,000. But currently we are going for a discount offer, which is 25% discount on 36,000, which makes it equal to 27,000 only, which can be paid in 3 installments of 9,000 each. And I repeat, the value of fee for per month of these classes which I'm conducting is rupees 3,000. And if you're joining for an year-long course, there is a discount of 25%, which makes it 27,000, which can be paid in 3 installments of 9,000 each, right? Every time before I end the class, I say something which is positive, something which is uplifting, something which brings positivity into our lives, right? So before I end this class, my simple statement is, जब भी आप कुछ पढ़ते हो, है ना, anything, whenever you read something, कोशिश करनी है कि you will connect it to whatever you have read before. जब भी हम कुछ पढ़ते हैं, अगर हम उसे जानकर कनेक्ट करने की कोशिश करें उससे जो हम पढ़ चुके हैं, तो वो नया कॉन्सेप्ट भी बहुत अच्छे से माइंड में सेटल होता है. ठीक है, दिस इज द गुड थॉट फॉर द डे. जब भी हम कुछ नया पढ़ते हैं, उसको कनेक्ट करना है विथ वॉट एवर वी हैव रेड बिफोर, तो हम देखेंगे कि हम उस काम में बेहतर बनते जाएंगे. एक छोटा सा गुड थॉट फॉर द डे था. लेट्स कनेक्ट लेटर ऑल्सो. आई विल शेयर माई टेलीग्राम चैनल का लिंक हियर सो दैट यू ऑल कैन कनेक्ट लेटर वेन एवर यू ऑल वुड लाइक टू. So here is my telegram ka link, है ना, 1 minute. Okay, so there must be a sharing option. Yes. तो आप लोगों के लिए मैं कोशिश करता हूँ कि इसको अपने टेलीग्राम चैनल का लिंक शेयर कर देता हूँ. ठीक है, ऑलराइट, यही करते हैं. सो दैट लेटर जब भी आप मुझसे बात करना चाहें या आपको किसी तरह का कॉन्टैक्ट चाहिए अबाउट द क्लासेस, आपको वो यहाँ से मिल सके. ठीक है, आई विल पेस्ट इट हियर. राइट, सो yes, I think Harshit Singh is asking. So Harshit, here is my contact for the classes. ओके सो आई थिंक नाउ यू कैन फाइंड इट हियर हर्षित. मैंने आपके लिए कॉन्टैक्ट पेस्ट कर दिया है मेरे टेलीग्राम चैनल का. प्लस आई विल ऑल्सो पेस्ट द कॉन्टैक्ट ऑफ माई इंस्टाग्राम for anybody of you to follow me over there. You can also get updates about my classes on my Instagram channel. So it is Khushwant Fatnani Physics, है ना? And same is the name for my Telegram channel. Thank you everybody for being a part of this session. I hope this session आप सभी लोगों को ये सेशन बहुत पसंद आया. मुझे पूरा विश्वास है कि मुझे कहने की ज़रूरत है ही नहीं. जो चीज़ आपको अच्छी लगती है आप अपने आप इसे लाइक करते हैं, शेयर करते हैं, सब्सक्राइब करते हैं, अपने दोस्तों के साथ शेयर करते हैं. तो लेट्स कीप मेकिंग श्योर दैट वी ऑल आर कनेक्टिंग थिंग्स. जो पहले पढ़ा और जो आप पढ़ रहे हो उसको कनेक्ट करोगे तो लाइफ और सरल और मज़ेदार होती जाएगी. थैंक यू एवरीबडी और सभी लोगों को बहुत बहुत नमस्कार.